Alright, everyone. March 28th. Reducing dishes. What, washing dishes? A chef has collected data on the satisfaction level of his N dishes. Chef can cook any dish in 1 unit of time. Like time if coefficient of a dish. A like time coefficient of a dish is defined as the time taken to cook that dish, including previous dishes, multiplied by its satisfaction level, time I times satisfaction I. Return the maximum sum of like time coefficient that the chef can obtain after dishes preparation. Dishes can be prepared in any order, and the chef can discard some dishes to get its maximum value. Okay, so we have a satisfaction. Okay, can cook any dish in 1 unit of time, and I can cook in any order, and I want to maximize the sum. So basically I have satisfaction, and I can rearrange them. Anyone can come out first, and this result is after removing the second. Wait, hold on. Like time coefficient is the time taken to cook that dish, including previous dishes. So you might want to keep some of the negative, just so that we get the time up. Like the first one, I keep -1, and I do a 0. Then I can accumulate time to 3, and then I can do 3 times 5. And for this one, 500. We're looking at, yeah, this is without a doubt DP. Just need to find a way to do the DP. Like, how can we DP this thing? So, and they have different time. That's the tricky part. How do we handle the different time? First, so what we can say is, let's say we have satisfaction, and someone is taken at a certain time. What is the maximum we have so far? Yeah, because, well, the thing is it always going to be the maximum? And it can discard things. So it doesn't even have to be. Oh. Yeah, I think it's if I take a dish at a certain time, right? What is the maximum we can achieve? So for each dish, I can take it at 1 unit time, 2 unit time, 3, 4, 5, all the way to the end, right? And for each one, I need to know what's the, yeah, so at 1 unit of time, right? At 1 unit of time, I have these dishes, right? I have -1, -8, 0, 5, -1. So that's 1 unit of time. If it's a 1 unit of time, the coefficient is going to be -1, -8, 0, 5, and a -9. Now at 2 units of time, if I cook -1 at 2 units of time, what is the maximum we can get? Well, at 2 units of time, we are going to get 2 times -1, and we need to plus the maximum of 1 unit of time. That's not itself. Okay? It's not itself. So the maximum of that's not itself, is going to be 5. So we can cook 5 and then cook -1. That will give us 3. And for -8, if that's the second, so it's -16 plus 5, which is 7. No. Minus 16, that's minus 11. If it's 0, that will be 5. If it's 5, that will be 10. If it's this, minus 18, minus 13. Right, we just need to find the largest and the second largest. Right, that's all we need, the largest, second largest. We might as well just sort it. It's easier. Okay, so now at 3. 3 will be minus 3 plus the biggest on the stand 2. Ooh, what if you have already done? So we have to also keep track on what dish have we cooked, because each dish can only cooked once. Ooh, so we have to record. So this is cooked by dish. Man, we have to index 0, right? 0 and 2, 3, 0, 3, 1, 3, 2, 3. And this is 3. That cannot do 3 again. So that's just 3, 2. This is 4, 3. Okay, so now 3 dishes. 3 dishes will be 0, and then we're going to find for 2 dishes this largest. Well, that's 3, 2. So we have 0, 3, 2. That gives us 13. For here, minus 11, so we have 1. That's minus 24. Right, and again, we can go 3, 2. 1, 3, 2. Right, minus 24 will be minus 14. And then this will be 2. Cannot take 3, 2 because I already taken it. Right, so the next largest is this, cannot take. The next largest is this, so 2, 0, 3, which will give me 3. This will take 3. And we cannot take, cannot take this, cannot take this, cannot take any of them because all of them has it. Then what do we do? The largest one has everybody. Everybody's taken it. Dude. What does that mean? Huh. Because I want to take it now. Then I want to find on the second level what's the largest that does not take this. Man. Because everybody takes this. Hmm. I don't know, man. The best will be the largest multiplied by everything. This multiplied by this, so we can say 5 times 5, 0 times 4, and then go all the way down till we get a value. Or we can say we do 4, 3, 2, 1, 3, 2, 1. Does that work? We just sort satisfaction and go right to left. We can go to left to right. Yeah, we sort satisfaction and then we have the largest value. And we say the best will be the largest value multiplied by size of satisfaction. And then the second largest multiplied by the size minus 1 and all the way down. And then we can compute what is this value. So we have 1, and then we can reduce. We say we want to cook 4 meals. And of course, we want 4 meals to be as big as possible. And then we get it. You know what? Let's get that up and see how that one goes. That might actually be the case, given that the pass rate is 70%. So I actually think this might actually be the solution, right? Okay, and then we say n equals len satisfaction, rest equals 0, right? And then we can say for n in range, we can cook this all the way to cook 1. So we do this, okay? And then we say for I in range all the way to n, because we want to cook this much. Then we say temp equals 0, right? Temp plus equal to satisfaction I times n minus I. And then when we're done, we say res equals maximum res and temp. And then we'll return res. Ting. $20. 0. I mean, there may be a early stoppage, but yeah, I guess. And I think the first time it drops down, that shall be it, because the maximum value is getting lower, right? Max value is getting lower. See if the value drops down, right? And the next one, I'll just submit this. Give this a shot. Yeah? 999. Tomorrow will be the day. Tomorrow will be the day. I wonder if we can like have an early stop. So greedy, right? So they count as greedy. The best scenario for each number of dishes to take is to cook the dish with the highest satisfaction, right? The last, the second highest satisfaction, the second to the last, etc. Now we can obtain the max sum of like time coef for each number of dishes, and then just obtain the max amount. Yeah, you kind of can guess it's going to be O(n) squared because it's 500. 500 O(n) squared is likely. Now, what I wonder is if the temp starts to go down, is that a signal? Well, for one thing, the positive definitely is going down, right? It's definitely going down because every one multiplied is going down. And the negative is also going down. Now that's something. So if we have a lot of negatives, and then we're reducing the negative, this thing will go up. And then once it goes down again, you know what? I do think, I don't have a full proof, but I think if the temp, if this starts to go down, maybe that is a sign. Let's give this a shot. So it's exactly the same, but we're gonna have an early stop. Same as solution 1, but with an early stoppage. So here's what I think. So temp will equal to, right, sum for this satisfaction. Right, I'm gonna say if temp is smaller than rest, then we're gonna break. Otherwise, or say smaller equal to. Actually, might not, because the positive goes small, the negative goes small as well. But no, it could have a positive really small and a negative really big. Okay, the negative can be really big. So at the beginning we're just giant negative, right? Giant negative. And then we'll hit a point where we become positive, right? And then we keep going. We take more negative out. We'll take less negative out. So the amount of drop is, the amount of negative drop is actually bigger than the amount of positive increase, positive drop. So the previously I said take away 2 giant negatives, but now I take away 1 giant negative, right? And my positive is dropped a little bit. So overall, I have a win. Yeah, that's how it gets bigger, right? It gets bigger, it gets bigger, it gets bigger. But at a certain point, after we're doing this, it starts to go small, which means the power of the negative taken away cannot counter the amount of positive going down. So I still think this might be right. I was just going to say it might be right. This is not right. This is not right. I can't even pass the first one. Really interesting. Very interesting. Oh, it's the beginning. Oh, we need to do this. If rest is larger than 0, else is 0. So we have to do something like this. Let's try. Not sure, but worth a shot. Yeah. Early stoppage. Early stoppage is much faster. Although this technically is still O(n) squared, but early stoppage allows it to speed up, right, to this. Now we can check the solution. So am I doing DP? Oh, I'm doing greedy. Oh, that's not greedy. Hold on. What did I do then? Maybe this is greedy. This is definitely greedy. We need to read. Quote this dish at its satisfaction value. And then move on to the next dish, whose time taken will be 2. So we can take any one of them, for 2. The second option is to skip this dish and move on to the next. Well, the number of dish yes. Wanna try? Yes, I do. Okay, so this is where it starts to become interesting. Top-down DP. Okay, def DP. We need an index and num dish. How should call it dish? Okay. Wait, don't return anything. I don't want to return anything. I will have a self.res will become 0, right? So current have dish, and we say if index is equal to n, right? It's equal to n. I'll just return. Otherwise, we'll take this, right? Oh, we need to know the previous. So previous coef. Okay. Then we say coef shall equal to, because I'm taking my current one, then it should be plus equal to my satisfaction index multiplied by dish, right? And self.res equals maximum self.res coef. Once I'm done, oh, that's 3. No. We'll return a coef. That will be returned 0. So basically, we are going to say res equal to so either take it or not take it, right? So I don't have to use this then. Currently res is this, and then I can either take it or not take it. So if I take it, then so res take, okay, Then for I in range, index plus 1 towards the n, we're going to do dp I dish plus 1. Right? Whereas take will be satisfaction times dish. So I take this and I will do the remaining. And, oh, actually, no. Because I want to find a maximum among them. So it should be plus maximum for this dp I and dish plus 1. Okay, so take, and then rest not take shall equal to this, oh jeez, dish, right? And then we'll return the maximum of either take or not take. This is like a knapsack. And we just return dp index 0, dish is 1. Because I can take this or not take this, right? And of course, we need to value cache it. Okay, let's try. Max argument is the empty sequence. Huh. Could have been like perfect, but now what? Because I think it's just how would it become an wait, hold a second. No. I think its index is already n minus 1. It's already n minus 1. If index is n minus 1, then we won't be able to do this, which means I shall do this then. So we'll prevent that this will never reach n minus 1. Because if index n minus 1, I already handle it. So it's not 0. So n minus 1 should be the maximum of 0. And dish multiplied by satisfaction index. That's that. That's interesting. $16. Oh, I need to Holy crap. Everyone can be taken as the first. No, I handle. So hold on. The first one can be taken. So it's not dish plus one. It has to be. Yeah, so for the current one, I can take. I can take it as 2. I can take it as 3. How do we handle that? Number of dish. So we say if it's the first dish to take, right? It's the second dish and the third dish to take. But we shall start, we can say any one of them can be the first dish to take. Or we can say this can be the first dish to take or the second dish to take. How do I handle that? Let me think. Hold on. If this is the first dish to take, then what's my next dish to take? Anyone can be the second dish to take. Wait. Hold on. We start with 0, 1, alright? And then we'll cook. So next one will be 1, 2. Cook. If I skip, that will be 1, 1. If I skip. What did I do Yeah, number of dishes cooked so far. Is this right? I guess it is right, but huh. I just plus 1. I don't do this. Hold on, let me think again. I either cook or don't cook. Right? If I cook it at this time, then the max will be the remaining. So what it says is just dp dp index plus 1 and dish. It's the same thing. It doesn't work. And I think I'm doing the same thing, right? You need to sort it. Oh. I forgot this one. We have to put the greedy in it. We have to put the greedy in it. Yeah, now it makes sense. Now it makes sense. Why? Well, because you always want to cook the dish with highest later. So that's the DP. That's the greedy part. Now it makes sense. Now it makes perfect sense. Now we don't even have to do the other part. We can just do this and do this. Now it becomes extremely easy DP problem. Right? This is take index, take current dish. This is not take current dish. The maximum will be the next one. This is greedy. A little bit greedy here. Bottom up. I'm too lazy to bottom up. It'll be the same thing, bottom up. So everything will depend on. So if I want to know, if I know everybody, so if I want to get a maximum of me, right, for all of taking the first one, right, the second, if I want to take this, if I don't take it, then the maximum will be the max of this, right? If I want to take myself, then I can take myself as the first dish, second dish. If I take myself as the second dish, I need to find the first dish. So we go first dish. If I take myself as the second dish, so I need to find a max of first dish. So I can get the maximum of previous up until this point. Okay, I'll take a 1 dish, 2 dish, 3 dish was the maximum, and taking all of them. So if I take 1 dish, I go by myself. If it's 2 dish, you know what? I'm interested to do bottom up. Okay, bottom up DP. Space optimized. I'm not sure if I can do space optimized. Actually, let's not say space optimized. We have to do this anyway, so it's a bottom up. So dp is equal to, hold on, let me think. I say dp ij is the max value of taking dish j as the ith dish. How about that? Right? And then with that, for dp, if I want to know dpij, right, so that shall equal to dp, if I don't take j, right, if I don't take j, so it should be the ith dish j minus 1, and dp, if I take it, so I minus 1 dish j minus 1, so the maximum of these two. So they're both pointing to j minus 1, right? There's current level j minus 1, another's previous level j minus 1. So 2 shall be sufficient. So if I do that's satisfaction. No, I'll copy it. Okay, so that's the first level. With everyone take one dish, and then say for I in range 1 all the way to n. Actually, no, 2 to n. 1 dish. All right, we've done 1 dish already. So 2 to n. All right, 2 to n. And we can say temp equals, say 0 times n. For j in range n. So for each one, we can say temp j, right, shall equal to maximized same level j minus 1 or dp j minus 1. And of course, j minus 1 will give me trouble because if you're the first one, so that is something to concern. So I don't think we should start with 0 because let's say we're cooking 2 dishes, right? You're the second dish. So the first dish must be, you cannot be the second dish. So you have to be the second one to cook. It can be the first cook. If you're the first one, it's fine. But if you're the second dish, that means somebody has already cooked before you, which means we can actually go from I, say my minus 1, right? With that, right, with that, so the first one, j will be 1, so I can have them, right? And then I should always cook the last dish, right? The last dish, definitely. But I have to keep track of the maximum along the way, right? I have to keep track of the maximum along the way. So this is just cooking one dish. It's this much. Cooking two dish. So I need to have a res equals 0, right? And then we say res will equal to maximum. Actually, res is not equal to 0. Res will equal to maximum dp equals maximum res and max temp dp equals temp. You know, maybe we can just do this dp. And now return res 4. That's not right. Because you forgot a take. I don't know why you do that. This is not take. This is take. We have to mod plus the ith dish multiplied by satisfaction j, right? Can't forget about that. Still not right. Okay. That's not right. That's not right. That's not right. That's not what dp is. Because the maximum so far, right? Up until this, what's the maximum? So that's not right. I think this shall be 0. Okay, and 4 I range. No, it's right because I already sorted it. Hold on, this is right. I already sort this, so it's from small to large, right? It's from small to large. It's just if it's 0, it's negative. We have to become, yeah, it has to be for Sing satisfaction. We shall do max S and 0, right? Res shall equal to dp negative 1. That's taking 1. Right, now we say 2 dishes. Okay. We have a temp. And then from the first dish, index of 1. So are you taking it? If you're not taking it, it's this. If you're taking it, it's gonna be the largest this plus this. Right? And then that shall be maximum not. Should be dp. The maximum dp. Should be the maximum, right? At this level, taking this many, what's the maximum over the entire thing? So it should be 9 minus 1. What the hell? Still not right. Hold up. So 2, 3, 4, right? And then, because we take 1, right? We're already done. And this is take 2, right? Okay, we say take 2. Oh, it didn't take 3. Shall be able to take 3. Okay, how about this? Ah, the first one's still not right. That's interesting. Hold on. All right. So we're taking 3. Doesn't matter, it's all 0. Taking 4, right? We want to take 4. Zero, 1, 2, 3. So we start from here, right? Take 4. So we can take 4 meals, right? 4 dishes. We want to take 4 dishes. No, no. This has to be. Because otherwise it doesn't make any sense. Maybe this is wrong. There we go. That's more like it. Zero. Have to be negative mass volume. Yep. Cannot be 0. Because we need honest coefficient. With on space time. Okay. I think we have one more thing to go through, the greedy. Okay, what's the greedy? What the hell is this? Okay, these are all the possibilities. So we want to find out the maximum among them. No freaking way. What? The difference between them. The difference between them is the full sum. Okay? Alright. Difference between them is a plus b plus c. Difference between them is a plus b. Difference between them is a. So if I pick, so the difference between them is a prefix sum, as I was just saying, right? The difference between them is a prefix sum. Hold on. We sort it regularly. So it's a plus 2b plus 3c plus 4d plus 5e. That's the first one. And the second one is b, 2c, 3d, and 4e. So the difference is a plus b plus e. And then next one, c plus 2d plus 3e. The difference between them is b plus 2e. Next one is d plus 3e. The difference between them is c plus d plus e. And then e, the difference between d plus e, right? So these are the differences. So what we can say is from this to this, right, we have this much difference. Or what we can say is, if we start taking this one, we want to find the maximum of among those, or maximum among those. So which means if I take this and I move on this, we want to see if it goes up, right? We just want to see if it goes up. Yeah, we're going to do the other way down. Let's go down. So do we go up? So if we start from taking this, taking e, taking the last one. Now we want to see if we want to take the next one, it's going to plus d plus e, right? And if this is positive, that means we're going up. And if this is positive, we're going up, right? Because we always want the largest to be in the end. And then we go up until a point where it becomes negative. If it becomes negative, then that has reached the end. Oh. So my early stop is similar, right? Similar to this. The real greedy. Right? Sort satisfaction from small to large. Right? Say we have A, B, C, D, E. We always want to take E. Right? So let's say we take E as the first dish. We have the current coef as E. Then we can try, right, take E as the second dish and D as the first dish. Then we have the coef D plus 2E, right? Notice the difference between the two is D plus E, right? Which is the suffix sum, right? The suffix sum. As long as D plus E is larger than 0, we are incrementing the total coef. Then we check d plus c plus d plus e, right? And b plus c plus d plus e, etc. We stop if a suffix sum becomes negative, right? That means any further suffix sum will also be negative because satisfaction has been sorted, and a negative suffix sum means the total coef no longer grows. So we stop there and return the current total coef. So we'll sort this, right? And then from back to front, we can say res equals to res equal to 0, and suff sum is equal to 0. I say for I in range, for I in range len satisfaction minus 1 minus 1 minus 1. Okay. And then we say suffix sum plus equal to satisfaction I. If suff sum is smaller or equal to 0, then we'll break and then we'll return res. Okay. Otherwise, res or plus equal to suff sum. That's it. Lordy. Oh. Lordy. This is good. Oh my god. Gotta be kidding me, man. Oh. This is good. This is very, very good. It is like deep analysis of this. Nice. I like it. All right. I'll be here for today. Well, it's a longer one today. I'll see you guys tomorrow. Adios.